Alrighty, so this is it. This is the big one. This is the 5.3 review. This is the assessment 3 review. So after this is the unit final, and it is the final before the end of the year, school year. Nope, nope. I keep messing that up. It is the final before the end of the calendar year, before full winter break. So let's go ahead and we'll just go ahead and get this thing started. First of all, coordinate geometry. Nope. I'm gonna move on from that. So we're going to classify each triangle by its angles and its sides. We're still on top of that. We're still working with that. So ABE. So I've got ABE. So I'll start out angle, angle, notate the angles here, and then sides. There we go. So starting with the angle, with this triangle ABE, so it's this here. I would have to say that it's obviously a right triangle because it's got the right angle there. By the sides, I know that the hypotenuse is 7. And based on what I know about the Pythagorean theorem and the fact that this one is clearly shorter, I mean, I know it's got to be, it has to be a scalene. Also, just by eyeballing it, if you don't see any congruency markers, if you don't see any hashtags like this on any of the sides, then it means that none of the sides are equal to each other. So you can just assume that it's scalene if you don't see any of those there. All right, so triangle BEC. So BEC, let's see. So, all right, so so this length up here is 2. And this length here is equal to 5, so I'll make sure to notate that. This other length here is 7, so BEC has two sides that are 7 in length. So that means isosceles triangle, as far as sides are concerned. For angles, that's just 3 acute angles. We have right triangles, we have obtuse triangles, we have acute triangles, and those are pretty much the broad ones. And then the only other specific ones are equilateral and right triangles. And so it's not either of those. So we're moving on from here. So DEF. So I've got D, E, and then F. Oh, DEF. Oh, that's equilateral. Just clear this one out here. There. All right, for triangle CDF. Oh, that one's all right. Well, for the angle, that is definitely obtuse. And then for sides, yeah, those are, yeah, definitely scalene. So yeah, there we go. That's the first 4. So yeah, for CDF, F is clearly obtuse. It is clearly greater than 90 degrees. And none of the sides are equal because we don't have any hash marks indicating congruency. Nor do we have, unlike with triangle BEC, we have a measurement of 7. We have another measurement totaling 7. So so if you don't have congruency markers, but you have other evidence indicating equality, then you can look at a drawing like that and say, oh, well, those two are congruent. With this case, I've got a side of 2, I've got a side of 5, and then I've got a side of who knows what. But it's definitely greater than 5. So yeah, definitely scaling. And like I said, we're skipping this one. So jumping straight down here. Now we're finding the measure of each missing angle. All right. Okay. Hmm. All right. Well, there's my research assistant. I'm trying to find, you do enough of these problems and you kind of want to find different ways of solving them. You want to find different ways of um, figuring out how to do them. Let me tighten this up a bit. Yeah. You want to try to find different ways of doing them and solving them so you're not doing the same problem over and over again, especially if you're shooting several videos back to one another. But sometimes you just got to work with what you know and what you have. So for angle 1, I know that angle 1 is a supplement to 88. So 180 minus 88 is going to give me 92. So I know angle 1 is equal to 92. Um, huh. Well, I just noticed that I've got parallel lines here. And I just noticed that I've got two parallel lines here. And so that means that angle 5 has to equal 81. Yeah, I've got two parallel lines here and a traversal through both of them. Alternate interior angles mean that number 5 has to equal 81 degrees. All right, has to equal 81. And so if number 5 equals 81, then angle 4 has to equal 180 minus 64 minus 81 has to equal 35. All right. Angle 3. So angle 3 is a supplement to 81 plus 35. So it's 180 minus 81 minus 35. Because again, angle 4 is 35 degrees. We worked that one out. So if I take 180, which is the whole line, take this one out and take this one out, that should just leave me with angle 3, which is 64. Okay, and then that leaves me with the measure of angle 2, which is going to be, again, 180 minus 92, which is the measure of angle 1, minus 64, which is the measure of angle 3. That leaves me with 24. And there we go. Again, you know, sometimes you just have to look a little harder. You have to use a little bit more reasoning to, you know, kind of find the extra evidence. But, you know, it's never impossible. It's just, you have to just dig through for a little bit more evidence from time to time. So for this one, all right, let's see. Well, I can see just right off the bat, number 4 is equal to 115 because we're dealing with vertical angles. I can see number 3 is probably going to equal 29. And the reason I say that is because just from trigonometry, there's a type of triangle called a 30, 60, 90 triangle. And so you've got the 90, you've got the 61. And so usually if this were 60, then I would know immediately that 3 was 30. But if it's 61, then that means that 3 has to be 29. So 180 minus 90 minus 61. Yeah. So 3 is 29. Then that means if 3 is 29 and 4 is 115. Oh, well, in that case, 180 minus 29 minus 115 is 36. Oh, all right. Well, that means that angle 6 is 36. All right. So let's see what else I can figure out. Okay, so I can definitely get angle 1 because 3 plus 80 is 29 plus 80 is 109 plus the measure of angle 6, which is 36, plus 36 is going to be 145 minus 180. So angle 1 is going to be 35. Okay, and then that means angle 2. All right, so 180 minus 80. I can't believe I used the calculator for that. Minus 35 means that angle 2 is going to be 65. All right. Yeah, we're going through this. We're working through this. Oh, if angle 2 is 65, that means that 5 also has to be 65 because it is a vertical angle. All right. And, ooh, I just noticed this. If 6 is 36, 7 is its supplement because it is its supplement. I mean, I don't know any other more direct way of saying that. And so 6 is 180 minus 36, which is 144. All right, there we go. So it all started with, I recognized that 4 was a vertical angle with 115. I knew that angle 3 and 61, I knew angle 3 was going to be something near 30 because it was 30, 60, 90 triangle. Yeah, because it was a 30, 60, 90 triangle. I knew 3 and 4, so I could solve for 6. I knew 80 and 3. I knew the combination of 80 and 3 and 6, so I could solve for 1. I knew 1 and 80, so I could solve for 2, solve for 5. And then I could solve for, well, no, I couldn't have solved for 7 because this is a quadrilateral. Because it goes from 5 to 7, and then there's a little space here to the 90, and then 61. Well, I suppose I could have. Because let me try something here, because a quadrilateral. So the rule is if the internal angle measurement is equal to the number of sides minus 2 times 180. So that's the total internal angle measurement. So I can use the space up here. This isn't necessary, by the way. You don't need to know this for the test, but it's just a little extra. N minus 2 times 180. And so a triangle has 3 sides. So that's 3 minus 2, which is 1 times 180, which is how the internal angle measurement. If it has 4 sides, minus 2, so that's 2 times 180, which is going to be 360. So that means I have 360 degrees to work with. So really, I should be able to go with, so 61 plus 5, which is 65, plus 7, which is 144, plus 90. Oops, missed a plus there. All right, so once again, 61 plus 65, which is angle 5, plus 144, plus 90. Oh, yeah, awesome. So that would have been another way to calculate angle 7. But yeah, if you would have written that on your work, I would have been extremely impressed. But anyway, yeah, it's just a little fun detour, just a little fun. Like I said, I'm here a while, so I got to find my own fun sometimes. All right, so with this one, it's a revisit of a problem that a lot of folks have a lot of issues with. So we have solving for x, given that all 3 of them are angle measurements. So what that means is all 3 of these represent angle measurements. And so what that means is if you take this plus this plus this, it doesn't matter what x equals. It doesn't matter what these expressions equal. When you add all of them together, they're going to equal 180. And so in order to solve for x, we're literally going to take this expression, add it to this expression, add it to this expression, and set it to 180. So what does that look like? So I'm going to combine all the like terms. That gives me 8 plus 6, which is 14, plus 3, which is 17. So 17x. And then I've got minus 35, minus 5, which is minus 40, minus 1, which is minus 41. 35, 5, 40, minus 41 equals 180. So that's all 3. So that's all 3 of these added together. That's all of them combined equals 180. So 17x equals, I'm going to take 180 minus 41. That's going to be 221 divided by 17. So x is going to equal 13. And yeah, there we go. If you really want to test to make sure that you have the right answer, take 13, plug it back into x, find all 3 of the angle measurements and add them up. All 3 of the angle measurements and add them up. You should get 180 by the time you're done. So moving on to the next one. This one, folks don't get wrong too much. This is a proof of the external angle theorem. So the external angle theorem is if you take a side of a triangle and you extend it out, and you extend it out a certain way, you create an external angle, hence the name, external angle theorem. And this external angle, whatever it is, and in this case it's an expression of x, is going to equal this angle plus this angle. So 11x minus 63 is going to equal these two added together. So again, we're going to combine like terms like we did with this problem over here. And we're going to get 5x minus 11 plus 2x plus 5x minus 11 combined with 2x plus 20. So 5x plus 2x is 7x. And then 20 minus 11 is going to be 9. So I'm going to move my x's to one side. So subtract 7x from both sides. That gives me 4x. Then I'm going to, 4x equals, then I'm going to add 63 to both sides. Oof. Get 72. And so 72 divided by 4, x is going to equal 18. And that is going to be my final, that'll be my final answer, Regis. And that will work. Generally, the best way that you know that that is the correct answer is, first of all, I got it. But also, if it's a whole number and not like a repeating decimal or a negative number or just some awful looking remainder or something like that, that's how you know that you've got the right answer. If it's some kind of a whole number, we're in good shape. So we've got the same kind of problem here again. We're going to combine like terms, and we're going to solve for x again. So I've got 9 plus 6 plus 3. So that's 9 plus 6 is 15, plus 3 is 18. So that gives me 18x. Now I focus on the integers. Wow. So I'm going to bust out my research assistant for this one. Negative 31 plus 17 minus 4 minus 18 equals 180. That's right. So 18x equals, can't help but think that this is going to be 11. (98) divided by 18. Yeah, x is going to equal 11. And we got x equal 11. So we can move on to the next problem, right? Oh, no, we cannot. We absolutely cannot. Because again, before we move on, or I shouldn't say again, well, it's again for me because I shot all of these in one day. Just because solving for x is important, it is key, but it is not what the question asked for. The question asked for you to find the measure of angle A. Measure of angle A. So finding x is absolutely necessary for finding the measure of angle A. But if you find x and then just move on, that is incorrect. That is wrong. That is the wrong way to do things. So in order to find the measure of angle A, we have to take x and put it back into that expression. So we have 99, which is 9 times x, 9 times 11, which is 99, plus 17. That means measure of angle A in this one is going to be 116. Very devious. Well, now that we know what to be on the lookout for, we're looking for the measurement of angle A. We're wise to you, little fella. We're keeping an eye on you. But we're going to do the same thing with the external angle theorem over here that we did in the previous problem, except when we find x, we're going to plug it back into angle A in order to get our final answer. So 10x minus 23 is going to equal 7x plus 5x, which is 12x, and then 26 plus 27 minus 53. Wow. All right. So that will give me 2x, 23 plus 53, 2x equals 30. So 15 equals x. All right. So again, we have x equals 15. but that is not the end. That is not the finale. That is not what we are done with. We just add it. We're just going to plug it back in here. So that gives us 5 times 15 minus 27. So that means measure of angle A is 48. And there we go. Now we're done with the problem. All right, now we're going to review isosceles and equilateral triangles. Remember, for isosceles triangles, if you have two congruent sides, the angles opposite those congruent sides will also be equal. So if this one is 74, that means that this one is also 74. So for the first one, we have angle Q. I'm not going to solve this one first. Instead, I'm going to go straight for angle R first, because angle R is actually going to be equal to angle P. So that's going to be 74. And that's just one of the properties of isosceles triangles. Again, if you have with isosceles triangles, you have two congruent sides. The angles opposite those sides will also be congruent. So if this is 74, means that one's 74. So for Q, so for this one up top, it's just a matter of 74. It's just a matter of getting 180 minus 74 minus 74. 74 minus 74. So in this case, Q is going to be 32. And there we have it. Again, we have an isosceles triangle. In this case, we have the top angle, and we don't know what the base angles are. So whenever I say the base angles of an isosceles triangle, I'm referring to the ones that are at the bottom of it that are opposite the congruent sides. The base angles of the triangle are the ones that are generally always going to be regarded as equal, because they're the ones that are going to be opposite the sides that are going to be congruent. So in this case, I've got the top angle at 106, but I don't know what the base angles are. Well, that's no problem. I'm going to take 180 and I'm going to subtract 106 from it. That leaves me with 74 degrees unaccounted for. So that means that this plus this has to equal 74. Well, that's not exactly what it means. It means that 2 times this equals 74. Because again, these are both equal. So 2 times one of these equals 74. So I'll divide it by 2, and that gives me 37. So each one of these is 37. And just to prove it, what I'm going to do is get my research assistant here. 106. Yep, that's what I have. So I've got 106 plus 37 plus 37, and we got 180. So there we go. And we've got another, oh, here we go. We've got another isosceles problem here. So with this one's a little bit more subtle, because before we had the sides and we used the sides to find the angles that were congruent. Now we're given the angles and we have to find the sides that are congruent. In this case, what it does is it highlights the relationship between the angles and the sides. And so if you have the angles that are congruent, that's awesome. If you have the sides that are congruent, that is also awesome. Because it's not that one indicates the other exclusively. It's not like only the sides indicate the angles and that's it. The angles also indicate that the sides are congruent, the same way that the sides indicate that the angles are congruent. So in this case, like I said, I've got 2 angles, and now that indicates that I have 2 sides that are congruent also. So when I'm looking at AC, for example, AC I know is congruent to AB, so that one's going to be 9 feet. And then as for angle A, that's just going to be 180 minus 48 minus 48. So that's going to be equal to 84. Alrighty. And for the token equilateral triangle problem, they're asking for the interior angle measurements. That is easy enough. They're always going to be 60. All right, moving on. Let's see, for questions 13 and 14, find the value of x. Yeah, looks familiar, but I'm pretty sure, I'm hoping that the goldfish memory holds true here too. So find the value of x. All right, so this is kind of like those isosceles triangle problems again. We're trying to figure out what these angles are. We're trying to figure out what these angles are equal to, and then we'll set that value equal to this term, and we'll solve it for x. All right, so I'm going to take 180 minus 34. That's going to give me 146. So I've got 146 degrees between these two angles that I have to account for. But I've got 146 degrees between these two equal angles. So I can divide it by 2, and that gives me 73. So because each of these is 73, I can set it up so that 8x minus 23 equals 73. And then this becomes a two-step, and then this just becomes a one-step problem. Or is it a two? I think it's a two-step problem. So 8x equals, what is that, 96. So I think that's 12. 96 divided by 8, which is 12, yeah. And there we go. Now for this last one, we don't have to do a great deal of thinking because the interior angle measurement of every single equilateral triangle, just leave this up here for reference, is always going to be 60. So 9x minus 3 equals 60. 9x equals 63. X equals 7. There we go. Like I said, I appreciate the fact that we have to ask questions about equilateral triangles and we have to have an idea about how they work. But still, there's only so much you can do with them. So we'll just move on. We'll move on from there. All right, so triangle CDE is an isosceles triangle with angle D congruent to angle E. All right. So I've got C. So D with angle D equal to angle E. So that tells me that D and E are at the base of it. So D, E, and so C is going to be at the top. All right. Is CD is 4x plus 9. All right. DE is 7x minus 5. Okay. And CE is 16x. There we go. I'll even put it on camera for you. And CE is 16x minus 27. Find x and the measure of each side. All right. Try to keep it, well, I drew it in the wrong place, but I'll draw it in the right place for the next couple problems. So again, knowing that it's an isosceles triangle and knowing what angles are congruent ahead of time means that I know that this side, that this side, and this side are congruent to each other. So that means I can say that 16x minus 27 equals 4x plus 9. So I'm going to go over here and I'm going to combine like terms. So that gives me 12x equals 9 plus 27, which is 36. So x equals 3. So with x equaling 3, I'm going to go over here to my drawing, but I'm going to write the answers down on the other side here as I go. So so for CD, 4x plus 9. 4 times 3 plus 9. 4 times 3 is 12, plus 9 is 21. And the cool part about isosceles triangles is I only have to solve for one of the two sides, and CE is automatically also 21 because these two are equal. And then for DE, 7x minus 5, so 7x is 21 because x equals 3, so 7 times 3 is 21, minus 5 is 16. And so there we go. Those are our answers. And now for the final page of the 4.3 review, I'll do a better job drawing the pictures here. QRS is an equilateral triangle. Oh, for crying out loud. All right, let's see. So I'll put it right here. QR is 17 more than twice X. All right. RS is 19 less than 6 times X. 6X minus 19. And then QS is 1 less than 4 times X. So 4X minus 1. Find X on the measure of each side. Measure of each side, over crying out loud. All right, so 4X minus 1 is going to be equal to 2X plus 17. Again, because it's an equilateral triangle, I can pick whichever sides I want. I can select whichever sides I want and set them equal to each other because they are indeed equal to each other. So that's pretty much it. So I'm going to subtract 2x from both sides. I'm going to take 2x from both sides, so that's going to give me 2x. I'm going to add 1 to both sides, gives me 18. X is going to equal 9. Let's see, so we'll do 4x minus 1, so 4 times 9 minus 1. So 4 times 9 is 36. Yep. Minus 1 is 35. So QS is equal to 35. And because it's an equilateral triangle, I can do this. There we go. I don't even have to do any extra figuring. I'm done because it's an equilateral triangle. That's yeah, that's it. I'm done. All right. In JKL, if JK is congruent to JL, ooh, all right, here we go. So drawing a triangle, if JK is congruent to JL. So what I see here, ooh, there we go. I'll even put it on camera for you. I see JK congruent to JL. What I'm reading here, I see that J is common for both of them. So I'm going to put J at the top of the Christmas tree here and put K and L at the base. And so all that does is all that really does, it keeps things orderly. It keeps things in a good place for me. J is 23x minus 4. K is 4x minus 1. And L is 9x minus 31. Okay, find x and the measure of each angle. So again, I know that JK and JL are congruent with one another. Because I know they're congruent with one another, that means that the angles that are opposite them are also congruent. So that means if the angles are congruent, I can set these two up in an equality. So that means 9x minus 31 is going to be equal to 4x minus 1. So solving through 4x, I'm going to subtract 4x from both sides, gives me 5x. Then I'm going to add 31 to both sides, equals 30. X equals 6. I get x equals 6. So now I've got to solve through for the measure of each angle. I'm going to solve through for this one first. 4x minus 1. 4 times x is 24. Minus 1 is 23. So k is 23. And because L is equal to k, I'm going to do 23. I don't want to do 23 times anything minus 4, so I'm just going to do 180 minus 23 minus 23. And that'll give me 134. And there we go. And that is our answer on how to get everything moving. Alrighty. Write 3 valid congruency statements for the triangles below. All right. Alrighty, let's see. Well, I know. Oh, okay, I know exactly what I'll do. I'll know exactly what I'll do. What I'm going to do is I'm going to start with Q, and then what I'm going to do is I'm going to shift Q from first position to second position to third position. And wherever else the other pieces go will be where they go. So we'll start out with triangle QRP, congruent to triangle T, and then SU, and then say triangle I'll say PQR. PQR is 213, is congruent to triangle UTS, and then triangle, I'll go with 321, so RPQ. And then 321 over here is SUT. Okay. So you can see, you can kind of sense some, you can kind of see some patterns here. So Q went from first, second to third position, but also T followed where it went. S went from second to third to first, so did R. And so even though three valid congruency statements, are they different orders? Yes. Are they basically the same order? Technically, yes. But again, we're working with a triangle, so we only have three points to work with. So there are only so many permutations of three things that you can use before you start overlapping things all at once. Before you start overlapping things, there's only so much there are only so many things you can repeat before you start overlapping. But the key idea is, if you're going to be writing congruency statements with congruent triangles, you have to make sure that each of the points still map, and that each of the congruent parts of the congruent triangles map to each other. That's the key thing. That's the key feature with the congruency statements. Otherwise, you're free to put the points in whatever order you want to, but Q always has to map to T, R always has to map to S, etc. All right, so this next one, for if KPL is congruent to ACM, complete each part. They thought by making this really small space that I wouldn't be able to draw my triangles. Well, joke's on them. So KPL triangle ACM. So I have my triangle set up here. I've got my similarity triangle set up. So KL is to AM, AC is to KP, PL is to CM, then angle P, angle C, angle K, angle A, then angle M, angle L. Like I said, the big determining factor on this particular type of problem, if you get the drawings done, the determining factor on how long it takes you to do this problem is how quickly it takes you to write the answers. By contrast, if you just want to stare at the congruency statement, you'll get it done eventually, but there's a faster way and there's a better way to do it, and it's just by literally looking at the triangles as they're it's just by literally looking at the triangles themselves. All right, so the next one, okay, WXY is congruent to HJI. So again, we have a congruency statement. So W is to H, X is to J. All right, I'll just leave that one alone. Looks busy enough as it is. And then I is to Y. I think that we're okay if I don't label the one obtuse angle. I think we're all on board with me saying, you know what, let's not make this any busier than it has to be. So JI is from obtuse to 2. From obtuse to 2 on this one is 16. So JI is going to be 16 meters. JH is obtuse to 1. From obtuse to 1 is 15 meters. So there we go. Measure of angle W is reference angle 1, which is 37. Measure of angle J is 6. Measure of angle J is equal to, measure of angle obtuse is equal to measure of angle obtuse, which is 114. And so now we just have to figure out what the measure of angle I is. Well, we've got two angle measurements of congruent triangles, so we're just going to take 180 minus 114 minus 37. And that's going to give us our final one of 29. So there we go. Alrighty, so what are the methods to prove triangles are congruent? Oh, this is going to be so embarrassing if I mess this one up. Well, I'm definitely not looking at my notes. That would be cheating, because yeah, I would never do that. Here we go. Yeah. So yes, using my flawless memory, the methods that we have to use the congruency to prove congruency. We'll start with the sides. So if we have three sides, we have side, side, side. Then we have side, angle, side. We have the offshoot of side, angle, side, which is hypotenuse, leg. Then we get onto two angles where we have angle, side, angle. Then we have angle, angle, side. And I think that's it. Yeah. Yeah, we just have those. Okay. Well, I guess yeah, I guess my memory is pretty decent. Just start out with the sides, work your way to the angles, and then but a key one is we don't have angle, angle, angle. That one was for similarity, but yeah. All right, so determine if the triangles below are congruent. It's yes, state which method. So I've got a congruent angle, I've got a side, and I've got another congruent angle. So angle, side, angle with the side between the two congruent angles. So yes, angle, side, angle. I've got two sets of congruent sides with a shared side. So yes, by side, side, side. I've got a set of two sides that are congruent to each other. I don't know about the third, so I can't use side, side, side. I know about this angle. So can I use side, angle, side? Nope. Can I use angle, side, angle? Nope. So nope. And for this last one, I've got a right angle. So I can use, so if I want to, I can use hypotenuse, leg. So do I have a congruent hypotenuse? Yes. Do I have a congruent leg? Yes. So there we go. So that'll do it. Yeah, so that is the final review sheet before the final assessment of the semester. So yeah, best of luck to everybody, and I'll see you during test day.